Welcome to yet another video on SRID Cloud. In this video, I want to talk about the dynamic NAT, the network address translation with a pool and so on. So refer to my earlier video on the static NAT, and this one will be on dynamic NAT. So let's get started. And here is a topology. There is a network 192.168.1.0 on the left connected to a core router, which in turn is connected to an edge router through 172.16.1.0 network. And the edge router is connected to an external router with a 10.140.10.0 network. And there is a network connected to the external router as well, and that is 10.20.30.0/24. So the intention is to let the PC1 on the 192.168.1.0 network to talk to PC3 on the 10.20.30 network. But these two networks do not know anything about each other, and so it has to be NATed. The communication from the PC1 should flow all the way to the core and then on to the edge router, where it will get translated into an IP address that is known to the 10.20.30 network, which is 10.140.10 network. So what we are going to do is we are going to set up an ACL so that all communications from 192.168.1.0 should flow through, and we will create a pool of few IPs in the 10.140.10 network and then connect them together. So let's look at the configurations one by one. So let's look at what is on the PC1, and that is this one. So let me make it larger. So its IP is 192.168.1.2 and its gateway is set to 192.168.1.1. Now let's look at the PC2. Make it bigger. So 192.168.1.3 is its IP and gateway 192.168.1.1. So now let's look at the switch on the left. And I wanted to make sure there are no VLANs, nothing in this configuration. I just want to make sure the ports fast Ethernet 00, 01 and 02 are all in up state, not in down state. Let me bring it over here. Make it bigger. And as you can see, the fast Ethernet 00, 01, 02 are all in up state. So now let's look at the core router and its configuration. So here it is. Make it bigger. So let's skip all these things. The Gigabit Ethernet 1 and Gigabit Ethernet 2 are the two connectivities. The Gigabit Ethernet 1 being connected to the switch, and the 2 is connected to the edge router. The IP addresses are all set to 192.168.1.1 on Gigabit Ethernet 1, 172.16.1.1 on Gigabit Ethernet 2. And here is the BGP relationship between the core and edge routers. The ASN for the core router is 62,000. The router ID is 172.16.1.1. I think this is a convention that is followed. It is simply set to the IP address on the end of the router. And the neighborhood is now set up to the edge router. The edge router's ASN is 63,000 and it is reached via 172.16.1.2. And redistribute connected. Make sure that everything that is connected to this router, core router, which is 192.168.1.0 network, is distributed to the other end. And finally, default route is set to 172.16.1.2, which is to the edge router. So anything that is unknown to the core router will be sent over to edge router. And that is pretty much it for the core router. Now let's look at the edge router. So let's skip all these things, and Gigabit Ethernet 1 and 2 are given 172.16.1.2 facing the core router, and it is the NAT is enabled on it as an inside network, and the interface Gigabit Ethernet 2 is towards the external network, and that is configured as IP NAT outside with an IP 10.140.10.10. And a BGP is set. This is towards the core router only. No BGP is set to the external router, and its router ID is 172.16.1.2 by convention. The neighborhood is set to the core router 62,000 via 172.16.1.1, and address family IPv4 redistribute connected ensures all networks connected to it or distributed to the other end. And let's look at the IP route first. So a default route is created to point to the external router. So any traffic that is unknown to the edge will be forwarded to the external router. And we should look at the ACL first. So here is the ACL permitting all 192.168.1.0 network IPs. And here is the pool of only two IPs in it, 10.140.10.101 and 102. And the ACL and the pool are used to create the dynamic NAT. So IP NAT inside source list, one pool, my pool. So what will happen now is any traffic that is coming from PC1 all the way to the edge router, it will carry the source IP as 192.168.1.2 will be replaced by 10.140.10.101, which is known to the external router. So the traffic will flow wherever in the external network and then come back to the edge router, where the destination IP will get replaced from 10.140.10.101 back to 192.168.1.2. So let's see how this works, or rather I should say it should work, but let us demonstrate that. So from PC1, whose IP is 192.168.1.2, I'm going to ping 10.20.30.2, and it works. Similarly, from the PC2, I'm going to ping the same 10.20.30.2, and it works. But in this topology, there is no way you can make network traffic initiation on PC3 back to any one of these two, PC1 or PC2, compute endpoints, because there is no one-to-one IP address relationship between the NATed IP pool IPs and the PC1 and PC2. So that was described in the previous video with static NAT, where we attached a particular IP to PC1 and particular IP to PC2 from 10.140.10.0 network. So the reverse network traffic was possible, but here it is not possible. So this is kind of an outbound only traffic initiated from PC1 and PC2 going to the external route. Let's do one more interesting thing. So I'm going to run a packet trace. So what I'm doing is launching the Wireshark between core and edge router. And I'm also going to launch another Wireshark between the edge and external router. And I want to keep them side by side. Okay, and then I'm going to try the ping again from PC1. So now let's look at the traffic from the core router to the edge router here. The IP address is 192.168.1.2 as source and 10.20.30.2 as the destination. And the reverse is also using the same IPs. But here in this Wireshark between the edge router and the external router, the source IP got translated to 10.140.10.102 instead of 192.168.1.2. And in the reverse direction, the same thing happens, but the 10.140.10.102 got replaced by 192.168.1.2 in the opposite direction. In the forward direction, the 192.168.1.2 was translated into 10.140.10.102. So let's do one more interesting thing. Let's go to the edge router where the NATing was performed. And let me run show IP NAT translations. And you can see the translations here. So let us say if I add one more PC, let's say PC4 to the 192.168.1.0 network and try to do the same thing, it will not work because the pool size is only 2. It has only 2 IPs in the pool, 10.140.10.101 and 102, and it is already taken by the PC1 and PC2. So PC3 will not get another IP for translation, so it will not work. So make sure that the pool size is large enough to cover all compute endpoints from the source network. Hope you enjoyed this video and learned how to do the dynamic NATing. Refer to the earlier video I did for the static NAT for a complete understanding of NAT. In the future videos, I will cover the same static and dynamic NATs again, but with the help of VRF. What if the core router and edge router are connected or on one particular VRF, and the edge and external routers are connected to some other VRF, or on global routing table. So thanks for watching and have a wonderful day or evening or night, and I'll see you all in another video very soon. Bye for now.